somera mu ddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts and sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga.
Reading. I would like to start by encouraging you. I want to talk about self-confidence. I want to talk about self-confidence, that as a student, in order for you to be academically successful, you must up your self-confidence. You must make sure that you identify the strength that makes you the best that you can be. And after identifying those strengths, align them or arrange them in order of execution. Arrange them in a way and identify the procedures you are going to use to implement them to attain that success. And secondly, I want to tell you about concentration. That if you are interested in achieving any goal, your degree of concentration matters a lot. Your degree of concentration matters a lot. I want to thank my current and past students and all students in this country. And I want to use one story that I normally share with my students. Let me share it with you, those that are privileged to attend my lessons all over the country. That there was a strong wind. There was a strong wind. One of my past students reminded me over the weekend on my YouTube channel. And he said that I remember you because you motivated us. I used to share with them a story of fish. There was a strong wave on one particular lake. You can assume it is Lake Victoria. And that wave came with a lot of strength and swept a lot of water on the beach. When the water was swept there, the water came with fish. That water came with fish, and of course the water found its way back because it was a wave. For those who are physics students, even those who are not physics students will understand. Now a lot of fish, young fish, was left there struggling. You know, fish survives very well in water. Now they were out of the water. They could not swim back because the water was not there. And one passerby saw the fish struggling and bent down, picked a handful and threw it in the water, picked another handful and threw it in the water. And as this person was throwing that fish, young fish, in the water, another person says, that's a lot of fish. That's a lot of fish. Do you think you'll help all of them? The person bent again and picked another full hand and said, it makes a difference. It makes a difference. He kept on throwing back in the water, emphasizing that it makes a difference. I want to encourage candidates all over this country and wherever they are, all over the world, that whatever small portions you keep on adding on will make a difference. We are going to look at a new topic today, and I want to emphasize that these topics that we are capturing and covering are selectively chosen. They are selectively chosen by Mr. Kakuru, particularly because you will discover that they are very prominent and very easy to do. Today we shall be looking at correlation. We shall be looking at correlation. It is still applied maths, and I want to invite you to enjoy the lesson. What is correlation? Mathematics is not full of theory, so I'm not going to overwrite things here. I will pick what is necessary, and then we shall get into action. Now, this topic looks at a relationship between variables, usually two or more variables, and these variables must be related. For example, it can look at items like sports. They consider, if you looked at your performance in both, your performance in midterm, and you look at how much energy you put in preparation for end of term or end of year, you can actually predict what you'll score. I have always told my candidates that I personally predicted what I was going to score in my S4 and my A level. And what I scored was very close to my predictions. So correlation looks at the relationship between two or more variables And the degree of this relationship is measured by what we now can call correlation coefficient. The degree is measured by what we can now call correlation coefficient. I want to look at the types of correlation, therefore. Very quickly, we have about 4 types. We shall have the one we shall call positive correlation. And summarily, since I have said it looks at a relationship of 2 or more variables, I'll consider 2 variables here. If a correlation is positive, it implies that the increase in one of the values will actually cause an increase in the other value, or a decrease in the other value will also ultimately lead to a decrease into the other value. And we can sketch a graph illustrating a positive correlation to look like this. Summarily, I'm saying that this is where increase in one variable results into increase in the other. From this graph, it shows that as y is increasing, you can see as y is going up, x is also increasing. Or as y is decreasing, coming back down, since the values keep on decreasing, this is also decreasing. That is a positive correlation. For the other type, can be a negative correlation, which is the opposite. And for those of you, of course, who know the gradient, what we talk about gradient, this a line that moves like this will always have a positive gradient. Will always have a positive gradient. And that is, now for negative correlation, we will look at a pattern that will move in the reverse. A pattern of that kind. That a decrease in y results into an increase in x, and a decrease in x results into an increase in y. That predicts or depicts a negative correlation. It depicts a negative correlation. The narrative or the narration, the explanation, I'm going to leave it out. For the zero correlation, there is actually no relationship here. There is what we call zero correlation. If we sketched the behavior of y against x for quantities or variables that do not show any correlation, the sketch would be showing variation of values without any particular pattern. There is no relationship at all. There is no relationship between the considered variables. With zero correlation, you won't find any relationship between the considered variables, and therefore we say there is actually no correlation. Zero implies no correlation. It implies no correlation. Often, I usually tell people that if you have no money, let me use money. If you have no money, that means you have zero money, and another one has no money but they have debts. The one with zero money but without debts is richer than the one without money but with debts, in the event that they are given any money. The other one with no money will have to start with that money, but one with no money but in a debt will definitely have to clear off the debt, and therefore may end up staying with nothing. Then we have a perfect correlation. The word perfect says it all. This is a correlation where it tends to relate with the positive correlation it tends to relate with a positive correlation, but this is a correlation where an increase in X, for example, meets exactly an equal increase in Y. And usually, because it is called perfect, usually the graph or the sketch graph here will give you points, if plotted, that will appear to be in a perfect straight line. The quantities, corresponding quantities, will always vary in equal magnitude with each other. And that is what we are calling the perfect correlation. Now, after looking at these 4 types of correlation, it will bring us to a summary of what we call the correlation ranges. The summary of the correlation ranges, I will ask my producer to take us to the next part of this lesson, where we have the summary of the correlation coefficient. I am not going to repeat that, but I will emphasize it right over there. That correlation coefficient has a given range. And as you can see, if I call that range alpha, if I said alpha is the correlation, the minimum and maximum, just like probability, is that the maximum correlation value should be less or equal to 1, and the minimum should be less or equal to negative. In that table, I do not include negatives, but I want to emphasize here that those ranges you have can equally be negative. Between 0 and 0.19, if you get a value of the correlation coefficient that falls within that, then we conclusively comment. They usually say, comment about your answer. We can comment and say, or interpret our answer as a very low positive correlation if the value is positive, or a very low negative correlation, or a very high positive correlation if it falls between 0.8 and 1.0. So the range, the maximum range of correlation is between -1 to +1. It must be less or equal to -1 or less or equal to +1. And we are saying on every question of correlation, the rule is ask you, calculate the Spearman's rank correlation between the variables, say X and Y, and comment. The first note there is that the sign associated with the correlation coefficient represents the type of correlation. Like I've said, if it is a positive value, then we call it positive. If it is very high, for example, that 0.87, we say it's a very high positive correlation. If it is negative 0.35, we say it's a low negative correlation. That is that area where they say comment or interpret your findings. We can move on to look at our examples. We can move on to look at our examples. I'll request the producer to move to the next page. Yes, we are going to look at Spearman's rank correlation. And I want to emphasize to the candidates attending this lesson that rank correlation is the degree of the relationship between 2 variables. We are bringing in the word rank. That means that the 2 variables are going to give you either, I want you to take note of this part. I want you to take note of this part, that there are questions where they will give you ranked variables already. If the variables are between 1 and 9, or 1 and 10, depending on how many they are, and they are giving you 1, 2, 3 for X, 3, 8, 7 for Y, you know that they have already ranked those variables. You don't need to rank them again. Simply find their differences as we are going to see the formula, and then proceed to look for the correlation type. There are 2 types, but I want to emphasize Spearman's rank correlation. Why? Because the question is usually open. The question is usually open, and whether you use Spearman's or use Candles, you always get the same answer. We are going to note that the higher the value of the correlation coefficient, the greater the relationship between the 2 variables. If we calculate and we get a very high value that we have categorized under very high positive correlation, it means the relationship between the variables we are comparing will be high. If we get a very high but negative, I mean like you get negative 0.85, it falls under very high. It means that the divergence or the difference between the variables is extremely big, that they cannot even be related at all. Now, as I've said, there are two methods. We have Spearman's and Kendall's, but we are going to focus on Spearman's, and we use a symbol that for Spearman's. For Spearman's rank correlation, the symbol we use is similar to the symbol we use in physics for density, but the most important is the formula. We say it is equal to 1 minus 6 times the summation of d squared over n into n squared minus 1 over n into n squared minus 1. What is important to note here are the explanations. That n will look at the number of pairs. Remember, we are relating the number of pairs. If I am relating x and y, how many variables do I have? Are they 5 compared variables? Then it would mean the value of n will be 5. And d will basically be the difference in ranks, the difference in ranks of the variables in question. I will request that you can expose both of the two numbers. We are going to start with that number 1 as our first example. We are going to start with number 1 as our first example. And I will, as I've said, rank it straight away. I will rank it straight away, and we shall slowly but steadily be able to go through that working. Slowly but steadily be able to go through that working. The question says, as usual, for the candidates out there attending this lesson, I want to emphasize that you can take a snapshot of that work, but we have enough time to focus on them. So in the interest of having the questions ready in your phone, you can take a photo so that we can study together. Now, the solution for that question, as I've said, if you look at that, we have 1, 2, 3, 4, 5, 6, 7, 8 pairs. We have 8 pairs. So this is paper 1 and paper 2. I will choose to use the ranks. I will let R1 and R2 be the ranks of paper 1. Okay, I can say represent the ranks of paper 1 and paper 2 respectively. Let R1 and R2 represent the ranks of paper 1 and paper 2 respectively. And what are we going to do? We are going to say this is R1 and then this is R2. Now we are going to use, the most commendable is to use ascending order. Ascending order is where we start with the highest, that is number 1. The highest mark scored in paper 1 is given a rank of number 1. And that means that the lowest, the smallest, will be given the smallest rank. In that case, the highest mark for paper 1 is 90. So I will keep them in that order. I'll keep them in that order. This table is going to increase. So I can choose that I will use it at that range and say that for R1, 90 is the first, and that is the second last. And 90 is the first, followed by 82, followed by 60, followed by 55 in that order. And since there are 8 pairs, the smallest, which is 27, is number 8. So it means that if we are ranking these values, I will be able to have in that table you have, at 50, At 50, I'll be able to have that as 7. I'll take that as 7. At 27, I'll take that as the smallest, which I'll give 8. At 82, I'll take that as the second biggest. I'll give it 2. At 55, I'll take that as 4. And at 35, that will be 6. At 60, that will be 3. At 90, that will be 1. And at 40, that will be 5. So I award ranks in that order. And without changing, if you award paper 1 starting with the highest, you don't need to change the pattern for that particular number. That means with paper 2, as I award the ranks, again the highest mark is given number 1. Incidentally, the highest mark is still paired with the 90, because usually this is a student. We are looking at each of those marks scored by a particular student. And from experience, the marks that students score in a particular subject always correlate. If you know, you know. They always correlate. So if I look at the ranks of these other students here, I will have for R2, I will have, where I have number 1 is still my number 1. Where I have the smallest here is 37, so that will be 8, which is the last. We started from there. 43, the highest is 83, followed by 76. This will be number 2. Followed by 68. 68 is with the number 2 here. This is number 3. Followed by, I know you are pairing. I'm doing it right there. By 50, and that will be number 4. 50 is paired with 35, which is 6. Followed by, after 50, we go to 44. 44 is paired with 55, and that will be number 5. After that, we go to 43, which is paired with this one. That's number 6. And then after 43, we will go to 40, which will be number 7. And finally, we'll have this as the smallest. My emphasis here is that as we give the ranks, we should have in mind that should we have had students who scored the same marks, as we shall see in our second example, we would continue giving the ranking. If you score the same marks, 2 students score the same marks, we give them the same rank, but we eventually get the average of those similar ranks, and we give them that average. So after getting the rank, the next is to find the difference. We have defined D as the difference, which we call D, and then the next will be D squared, and we shall be done. We shall be done. So once we get the difference, we simply subtract. 7 minus 6, we shall be able to get our 1 here. 8 minus 7, we get 1 here. 2 minus 3, we get negative 1. 4 minus 5, we get negative 1. 6 minus 4, we get 2. 3 minus 2, we get 1. 1 minus that, we get 0. And 5 minus 8, we get negative 3. Just as simple as that. We square these values to obtain 1, 1, 1, 1. We get 4. Of course, you know negative squared will give a positive. We get 1, we get 0, and we get 9. As you have been able to see from the formula, we need to find the value of D squared. So I need to find the sum of this column. And this is very easy to add this particular number. 9 plus 1 is 10, 14, 15, 16, 17, 18. We are able to get 18 by 1 minus 6, the summation of D squared, state the formula first, into n squared minus 1. And when we substitute, we shall have 1 minus 6 times this 18 over their 8 pairs into 8 squared minus 1. After here, a candidate is expected to compute using their calculator, and when you compute, you will definitely get the value. I expect you to compute and get the value before I put the answer. There are many students that actually have a challenge in using their calculators, and I usually give advice, which I must give now, that if you don't own a calculator, because there are candidates out there that don't own personal calculators. If you don't own a calculator and you must do an exam, I always advise that identify the person who is going to lend you a calculator and borrow it early enough. Start getting used to that calculator, because different calculators have different usage of functions, so that eventually when it comes to the exam, you avoid wasting a lot of time. When you compute that, it should give you a figure that is 0.782857. Now, whenever you get an answer, as you see, they say, calculate the rank correlation coefficient. I told you they don't condition you, so you choose whether you use Spearman's or Kendall's, and I've said we shall stick to Spearman's. Calculate the rank correlation coefficient for the performance between the papers and comment on the relationship. If we look at this answer, a candidate is expected to have the ability to tell that this is either in a moderate or in a very high or in a high correlation range. And therefore, this answer, as you note, it is a high positive correlation. So you can say that this shows, you must comment by saying this shows a high positive correlation in the performance of papers 1 and 2, of paper 1 and 2. So after getting the answer, the candidate is expected to conclude. The candidate is expected to conclude by telling the examiner that the answer I have got, this one is that. And because I stated 2 decimal places, you can round this off to 0.79 and say it shows a positive high correlation between paper 1 and paper 2 marks by the students. This gives us the solution for number 1. I will allow about 3 minutes maximum for the candidates out there to copy this solution. The most important, or the core of this solution, is the ranking. Once we master the ranking and we know how to rank, then we are good to go. Candidates should also take note that we can choose to rank from the highest. We can choose to give the highest score number 8. If we have discovered there are 8 pairs, we can choose to give it number 8. And then as we come down, we keep reducing. We will get the same answer, but of course it is easier to use the ascending order. You give the highest as number 1, and you come going down. Usually, the number of pairs can be emphasized in a question. However, if it is not emphasized, you are free to count and be able to tell. I will wait a little while before I move on to our second question. Our second question, in the meantime, is also giving us grades of 6 students in 2 subjects examined at a midterm, which I have called MOD, and an end of term, which I have called EOT, where these students scored grades. These are A-level grades, ranging between A and O. Fortunately, these students, all of them passed. None failed as per the grades posted. They want us, again, to calculate the rank correlation coefficient for the scores in the two exams and comment. The questions will always be typical of that condition. Never will they actually dictate to the candidate that use this. The dictation, we can do it internally in school. If I want my students to practice on rank correlation using candles, I will set a conditioned question, but I want to assure candidates out there that UNEB will already set an open question here, and it is your choice to use the method that you know best. We move on to our second example. This second example presents an opportunity. It presents an opportunity. I'm going to put it here so that, let me recopy it here, so that the ranking is done clearly as different from the first one, where probably some people did not know how I got the things. We have DCB and ECA, like that. And here we have EC, I hope that's how they appear. Okay, let me keep the order that you have. The order is A. You have AC, E, B, C, D. And here we have B, D, E, and A, C, E. Now, that is the question. Of course, they are separated, and I don't want anyone to say, why didn't he separate them? We want to rank them. So since this is midterm and the other one is end of term, we said we have midterm and end of term, I'll let RM and RE be the ranks. You can choose any letters. You can choose to say RX and RY if they are X and Y. Choose what is easier for you. So we are going to start with this one. If I am using 1, this will be 1. This will be 2. This will be 3 and 4. Here. C and C will be given different ranks as I continue. But I will have to add 3 and 4 because they are the same and divide by 2. So for C, my rank will be 3 plus 4 over 2, which will be 3.5. That means you will have 3.5 here and 3.5 here. And that means we shall now skip the next value, which should have been 5. And our D will become, because they are supposed to eventually become 6. So our D will be, since this is 3 and 3.5, our D will be 5, and this will be 6. Eventually, we must still have all of them. This will be my first, followed by this one. This will be my third. And E, A, B, C, D. This will be my fourth. This should be 5 and 6. But we are going to add the 5 and 6. We are going to add the 5 and 6 here and get for E. For E, we have 5 plus 6 over 2, which will give their rank as 5.5. So when I finally form my table here for the ranks, I expect that since I am starting from here, going down, I will have 1, then I'll have 3.5, then I'll have 6, then I'll have 2, then I'll have 3.5, then I will have 5. And these ones I'll simply put what I've got, corresponding 2, 4, This is 5.5. 5.5. This is 1. This is 3. And this is 5.5. So we will have our ranks generated just like that. And next will definitely be the difference. This difference, D, we have said D is our Rm minus Re. It does not matter whether you choose to say Re minus Rm. Eventually, the D squared will still be correct because indeed it is squared. So if I get a difference here, I'll get negative 1. I'll get 3.5 minus 4, I'll get 0.5, negative. I'll get 6 minus that, I'll get 0.5. This is positive. 2 minus 1, I'll get 1. I'll get 0.5. I'll get 0.5. If I square here, I'll get 1. I'll get 0.25. I'll get 0.25. I'll get 1, 0.25, and 0.25. And if we sum up, of course, this is a half. Even this is a half. So a half plus a half is 1. 1 plus 2 is 3. So my summation here of D squared will give me 3. Will give me 3. I will use this space and say, using the formula that Spearman's rank correlation is given by 1 minus 6 summation of D squared over n into n squared minus 1. I already have my n here. My n here will be, there are 6 pairs. So I will have my rank correlation given by 1 minus 6 times my 3 over 6 times 6 squared minus 1 over 6 times 6 squared minus 1. And when we compute that, we should be able to get the final answer. When we compute that, we should be able to get our final answer as 0 point. If you use your calculators, my dear candidates, what are you getting? You get approximately 0.19143, and we have said we can always round off these numbers to 2 decimal places. So we can say that therefore our value is 0.91. It is very clear that our comment here shows that it is the relationship shows a very high, shows a very high positive correlation. A very high positive correlation between the tests in the performance between or of the performance of midterm and end of term. The relationship shows a very, very high positive correlation in the performance of midterm exams to end of term exams. Candidates here should note that for values that repeat, as we have seen, when you are awarding ranks, just assume that they will have 4, 3, 4, then those ones that are similar. Even if they were 3, you'd get 3, 4, 5, add, divide by 3, and you'd give each of them that, but skip the other value to ensure that your ranks or your pairs still remain the pairs at the start. They still remain the pairs at the start. I will again allow my dear candidates and any other students following this lesson, especially senior 5 students who of principal maths, this work here, if understood now, will allow you to definitely do the other numbers. Yes, we are going to take on one more number on the exercise over there. We are going to take on one more number on the exercise over there. And that number, I made it specific, that use Spearman's rank correlation. We are going to take on one more number and see. Actually, I would, if there was feedback, direct feedback, I would have requested you to do that very number, and then I see your answers. My producer, I request that you highlight number 1. Okay. First, wait. Let them take the picture when all of them are visible. Take the picture because the other 2 numbers will become your homework. The other 2 numbers will become your homework. And I want us to take on one more number since the time is still available. I want to assume that you are through with this one. I encourage you to take the picture so that my producer can highlight the first question and we attempt to do it right away. We attempt to work through it right away. Number 1, I will pick that question here so that we can rank it together. And we will take our time. We will take our time. Even if this lesson ends when we have not reached the answer, I am very convinced that you already know what to do. But I want us to move together and see. 80, 120, 160, and 120 and 160. That is for x. The variables here are x and y. And for y, I have 10, 20, 30, 10, 20, 30, 20. And I have 45. I have 30 repeated. And I have 100. And we are saying that there were x and y. These were accidents. Unfortunately, there were accidents recorded or reported compared to the registered vehicles. X is accidents, Y is registered vehicles in a particular country. And they are saying we should calculate Spearman's rank correlation coefficient and comment. I believe we can take on this number right away. And we start by identifying the ranks which we shall shift on our table that I will put here. So I will let Rx and Ry be the letters we shall use here to represent our ranks. I have 1, 2, 3, 4, 5, 6, 7, 8. That means that our pairs are 8. And therefore, we know our n. I would use the highest value. The highest value here is 160. So this is 1, 2. And we shall definitely already give them the average. That would be 1.5. So this would be 1.5. And this would be 1.5. That means we are supposed to go to 3. From 120, we have 160, we have 120. So we skip 2. This is 3, 4. And we are going to give them again 3.5 here and 3.5 here. And now it means we skip 4. So the next will be 5. This will be 5, 6, 7 plus this is 12. You have to confirm. So it means all these will get position 4. All of them will be 4, 4, 4. We shall skip number what? We shall skip number 1, 2, 3, 4, 5. We shall skip 6 and give the next 7. So this will be 7 and this will be 8. So I have 8, I have 7, I have 4, I have 2, I have 4, I have 4. There is one I have not ranked, sorry. There's one here. 20 is also appearing. We were on 2, 3, 4, 5. This is supposed to be 6, 7. So they will share. That is 13, so we shall take this as 6.5. 6.5, and we shall skip 7 and make this 8. So it means that when you are ranking, you'll have this as 8, 6.5. You have 4, you have 6.5, you have 2, you have 4, you have 4, and you have 1. Next will be our D. Our D, we all know by now that it is the difference between the ranks. And then we shall have, lastly, D squared. So our D, we subtract, we get 0. We get 0.5. We get 2. We get negative 1.5. We get 1.5. We get 2.5. We get 2. This is 0.5. It's negative. And then we get 0.5. When we compute, we have 0. We have 0.25. We have 4. We have 2.25. We have 2.25. We have 6.25. We have 0.25. And we have 0.25. 1, 2, 3, 4, 5, 6, 7, 8. You must verify. If we sum this, this is a half plus 8.5. This is 8.5 plus 0.5, that is 9. And this will give me 2.5. That's 11.5 plus 4. But we can verify to confirm that you are right. We'll cross-check by re-adding again. This is a quarter plus a quarter is a half. 6.75, 7, 8, 10.25, 10.5. Oh, it is changing. 0.5, 6.75, plus this 7, 9, 9.25, 11.25, 11.5. I think it is 15.55. It is 15.55. The pairs are 8. So we use our calculators and check that using this as 1 minus 6 times this summation, which is 15.5, over the pairs are 8, over 8 into 64 minus 1 will give you 1 minus, when you compute this, you'll get 3, and this will give you 90. I think it is 93 out of 8 into 63. If you compute, you should be able to get an answer. If you compute, you should be able to get an answer. And that answer should be in agreement with that very answer that is indicated right over there. That gives us the value that we are calling 0.185. I think this example, as you capture it, should be able to expose you fully to how a number on this particular concept of correlation is done. I will, of course, be ending right over here shortly, but I want to remind you to now capture and reconfirm those other answers Number 2, I have not put the actual answer in those brackets you see. So don't think they have any meaning there at the end. I was trying to give you the answers I expect you to get when you calculate. Don't forget to comment. This 0.815 that you get here it shows that there is a very high positive correlation between our variables x and y. My dear students, I want to thank you so much for attending this lesson. And as usual, I want to encourage you to continue subscribing to my YouTube channel. The channel is in the names of Teacher, T-I-C-H-A, Kakuru, D. And I want to thank all those that have subscribed. Continue sharing, continue liking, but most importantly, use it for academic content. I recommend it to a friend. I wish you the best. Have a nice week. God bless you. Gachali Mabaga.
Somera mu ddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi lusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisulo eby'omulembe, science laboratory ssaako ne computer lab.
Tujjukira ebiseera byewagendanga mu salooni ew'omuyooyoosi wo n'akuyooyoota n'ovaawo ng'omatidde ng'olabika bulungi ng'era oli mugumu nti buli w'ogenda okuyita kebeera embaga oba kasiki ka mukwano gwo mu buli ngeri abantu bajja kukyuka emitwe nga bakulabyeko. Essanyu lyaffe liva mu kuyambako okutuukiriza ebiruubirirwa byo eri endabikayo. Naye mu kaseera kano nga tulwanyisa COVID-19 obulamu bwo n'okwekuumaako bya mugaso nnyo gye tuli. Y'ensonga lwaki tukkubiriza okwekuuma ng'okozesa Movit Hand Wash, Movit Herbal Soap ne Movit Body Milk Soap okumala waakiri ekitone nnyo obutikitiki nga20. Era tuli bagumu ti singa onoobikozesa kijja kuyamba okwewala obulwadde bwa COVID-19. Tusigale nga tuli batebenkevu era tunyumirwa akaseera ke tumala ne famire zaffe. Tuli bagumu nti ng'eggwanga tugenda kuvvuunuka coronavirus.
Move it. All day confidence.
Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi lusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisulo eby'omulembe, science laboratory ssaako ne computer lab. Abasomesa baffe abatendeke mu kusomesa n'okubangula abayizi, kuno nga twongerako n'okukulembeza ebitone. Kati nno ggwe omuzadde omwana wo mulete mu kifo kimu kyokka ekigenda okumuyamba okwongera okunyikiza ebyo by'asoma, era ng'essomero liri limu lyokka ye Maryland High School erisangibwa Entebbe. N'okumanya ebisingawo tukubire ku nnamba z'essimu ez'owammanga.
Okwewala oba okwekuuma akawuka ka COVID-19 akalumya ensi yonna. Bino wammanga byolina okukola okuziyiza okusaasaana kw'akawuka kano aka COVID-19. Naaba engalo ng'okozesa amazzi ne sabbuuni buli kadde. Weewala okubeera mu bantu abangi buli w'obeera. Weewala okukwata mu maaso, ku nnyindo, ku mumwa n'engalo nga si nnyonjo. Kolola oba nyiza mu nsonda y'akakokolako oba okozesa akatambaala bw'omaliriza okasuule mu dustibini yo. Bw'ofuna obubonero obulaga COVID-19 sigala ewaka okubire aba Ministry of Health ku 0800 100 000 oba ku 0800 20